Yes, we are live. Uh, what are we discussing? What did we discuss last week?
Did we skip last week?
Yeah, we skipped last week, and the week before that, you were gone, Anuraj, but forgot what we were doing.
We talked mainly about the Walker, the Boogie rover, the Mars rover. You know that Reth and Venkat are assembling right now. Or,
Yeah,
no, Reth's daughter is assembling.
That's right.
we also talked of something else. I'm forgetting now. Anyway. Yeah, so you wanted to do your teardown of the Sunfounder, right? So you've discovered some things. Good.
Yeah, I figured out basically the rest of the details, except for I've done everything but the solar, but I had a bit of a epiphany with kind of the control system ecosystem that they provide, along with the ESP32 that I think would be interesting to discuss. I wanted to pull up, though, first I got one other unrelated thing. I did finally build my Linux computer, my adorable little Clockwork Pi dev term. It is extremely challenging to type well enough to do like all the what you might want from a Linux system, but it works, and it's sort of absurd. I don't know why I bought it, but it was kind of fun to put together. It's all very like modular, and you can kind of like, it's got like these are just clips on the sides. So you can unclip those and just like basically like take the whole thing apart. And then there's different CPU cores you can drop in.
And you've got what, the thermal printer integrated
and
as
it's
well.
got the thermal printer. I haven't tried that yet, but it goes in the top here,
Right.
like up in here, and then.
Okay.
And what do you mean you can drop in different CPU cores?
Yeah, so there's like a board that's just the CPU on it, and you can like pop that into whatever else, and then they sell a couple different like versions, including like a RISC-V core, I think. But it kind of sounded like from the forums that the most Raspberry Pi-ish one works the best, because just like the software ecosystem is too terrible.
What is this device called?
It's called a Clockwork dev term. Yeah.
And they provide it with their own version of the OS, like Clockwork OS or something like that, right?
It's ARM. The one I'm running is Armbian, but it's definitely their build that has a few patches, I think, for the hardware. Oh, there you go. You found it faster than I did.
It's funny how the keyboard, so is tiny first. I was expecting something bigger, okay?
Yeah. But, it does have like 3 USB ports on the side, so you can pretty trivially plug in like a real.
Apparently, they have keys like for like a video game.
Yeah, there's like directional keys and like D-pad. So I got to find some game that could register them. That seems like the right.
What is this?
Those are everything comes in like if you were building like a model plane or something, you know how like all the plastic parts are like together printed on a tray, I guess.
Yeah.
They're printed all together, right? So it's like that. So you just like you just take off all the little plastic pieces, and those were I think like sort of like press fit kind of clamps on and slash spacers. So like when you put down a board, it would go over some pegs, and then you put these little plastic cups on top that kind of holds it in place.
This is the one you have, the $239 one?
Yeah, I think that's right.
Okay. Yeah. Pretty cool. Yeah.
Yeah. Or no, mine's not the RISC-V one, but it's basically like that with a different core. I think mine's the older, like A02 or 04. Oh, I think I wrote it down. They probably don't make it anymore. A04. chip.
Okay, they are also trying to make some FPGA plus RISC-V and FPGA plus ARM board.
How
Yeah, I
do
mean, I think their big thing is like everything is open source and kind of like the framework laptop kind of stuff of like open source hardware. So it makes sense that they'd go kind of all in on RISC-V when available.
Can you type on it? Like, how easily can you type?
Kind of. Like, I definitely was like doing, the normal kind of like apps install various things, and like it kind of works. I definitely wouldn't want to try to like code for real, but it's probably easier than trying to do it on my phone, I think.
Okay. Like, it could be, the screen could be larger, and then you can always attach a USB or a Bluetooth keyboard.
Yeah.
But can the screen be expanded, or is it like a fixed size?
I think it's probably pretty fixed. And I don't. Wait, does it have HDMI output? It's got a micro HDMI, so you could conceivably plug it into a bigger monitor, I guess. Although, good luck getting your Linux system to work with another monitor. You're muted.
Can you share this one? I think you shared it when I was talking about the one I was building. Yeah, this looks kind of similar. Though it looks like it has a much bigger screen. So this is called the CrowPi. So it's RPi only. I don't think it's RISC-V or whatever. But yeah, the interesting thing is it's got like, I guess, a robotic style hacker kit of things in here. That looks like an ultrasonic sensor. I don't know what else is here.
Okay, this Clockwork Pi has a different form factor for game cells. So the one you have is kind of, I think, kind of a dev term, and then on the next tab they have a game shell.
Yeah, it looks kind of like a Game Boy style thing. Oh, so this thing you can actually like plug in. You've got like GPIO ports, and you can plug in components. That's kind of interesting.
It's like one of those Elegoo electronics learning kits, except it's in the form factor of an actual computer.
Yeah.
So yeah,
That's neat.
But can it be something else than RPi if it's in the same form factor? This CrowPi.
This CrowPi, I think, looks like it's only RPi setup, so the board must be designed only to accept that.
No, if it's like a 40-pin RPi connector, then you can just swap it out.
So what are the is that like a fairly standard CPU core kind of?
No, the RPi 40-pin and like the dimension form factors was started by this Raspberry Pi, but then since it became so popular, I think others have also started making their own SBCs in the same form factor so that it can be used in the places where RPi is used.
Okay, so this is kind of interesting that I only knew about the framework laptop before, and then of course people making their own like 3D printed RPi computers. But this is starting to look like a little cottage industry of like reasonably well built things. Oh yeah. The one
I was thinking because like I was talking to one of these guys in Griffin from EF, and he keeps, whenever he goes to conferences, so he keeps a Raspberry Pi or a small node running, and then he had a huge setup like that he carries in a small suitcase wherever he goes to conferences. And then I started thinking, like, if you could replace it with a little more powerful CPUs, RPi can also run it, and then basically you could have a small laptop that is like running the node anywhere you go.
Yeah, and this is the one I'm building. I already showed it in one of the previous sessions you weren't there at, but this is like about as standard a build as you can do with like the official RPi components. That's the official RPi screen and backboard, and then I picked the cheap thing. I think if I add up the cost, this will come in under $200, but it lacks some of the features these other full-fledged things have. But yeah, this is I actually started thinking of this as kind of like your base station idea, Rhett. I think it pairs really well. So there's the boring, like useful things you can do, like home automation and stuff. But I think the fun thing to do is like use this as some sort of like base station for rover type things. And the one idea I had was the camera I have, it's fixed relative to the screen. It'd be nice to put it on a gimbal and like, use that to like be the Overwatch station that tracks the rover around. That might be interesting. You get the bird's eye view for navigation as opposed to just the FPV camera on the rover itself, which I think should be useful. And I think on Mars, doesn't the Mars Observer or something, there's one mission that's in low Mars orbit that provides that kind of service for the rovers. Yeah. Anyway, yeah, thought it would be interesting to try that. So I'll probably try and like slowly work towards that. But yeah,
Yeah, I was thinking similarly for the dev term that might be a great like base station control thing for following the rover around when you don't really want to be tied to a stationary Wi-Fi network or whatever. But then I started using what Sunfounder provides on an iPad. So I was like, well, I'm not going to build an iPad app or whatever, but I'd like to have something, more rugged and cool. And then I started playing with this app, and I'm like, oh, this is kind of hard to beat for what they're doing. So I can talk about that a little bit.
What inspired me to do this, the Tumblr's iPhone app. It was like, I don't really like the idea of building a rover type project that's tied to like an app ecosystem.
Yeah, it feels kind of icky.
Yeah, it feels like this, even if it's much less functional, it feels like it would be better to have like a simple CLI or something rather than like a proprietary app running on Apple or something. Also, it generalizes less well. If you kind of want a field station or base station or something, an app seems like the wrong control metaphor somehow.
Yeah. Well, let me talk about the Sunfounder one, and we can see how it kind of fits in. But I want to share a couple of little like videos. I'm not going to do any live demos today. Pull that up. Okay, so the critical piece that I hadn't talked about before, I think we hadn't done yet, was this ESP32 cam that you just like mount on the front. A couple takeaways. One, having that servo, so it's on a servo, so we can like tilt up and down. Having that servo and like being able to just like encode or whatever controls and move this thing around was such a like visceral robot moment that I was like, why haven't I been doing more of this sort of thing? Because like just to like point it around wherever I wanted it through software was just like, oh damn, this is cool. And it makes robot noises as it goes back and forth. So anyway, highly recommend putting things on a stepper motor.
Is that are there 2 axes on that?
It's
cam?
just one axis. It's just like, yeah, you can just go up and down. No turning side to side. Which in practice seems like, well, because you can move the entire rover, rotate it, but you can't like change the angle of it. Yeah, so it kind of makes sense. But yeah, I'm like, I saw someone built a hackathon level humanoid little robot with like 8 of those little motors, and I'm like, oh, that'd be kind of fun to build too. Even though, of course, we're not building humanoid robots here, but they're pretty cool. Okay, so anyway, we got this ESP32 cam. The thing that really confused me when we first started to look at it was like, how is it? Wait, what? We've got this ESP32 one here that's more powerful than the Arduino. It can do everything. Why is it just isolated to this like one little function? Which still seems kind of like silly, but like it in practice it seems to be working really well. So, and how it works is that, well, actually, first let me show the videos here. It's pretty functional through Gravel and everything. And this is fully like first-person view navigated by my daughter. That afternoon, I think they had a couple of RC cars and this thing out, and they were just like all exploring through the backyard with different RC mechanisms. And I was trying to get some like just to see how well we could do the what kind of obstacles we could go over. And it was pretty hard to stop.
So it comes with the iPad app or iPhone app.
So it comes with an iPad app. And so what the iPad app does, and I don't have a good shot of that, but maybe I can pull up what I'm doing here on my phone, which also isn't the best example of this, but so when you pull up the controller, you basically create your own controller by putting different widgets in these different spots. And so you go, I think this is in edit mode. So you go over here and you say, oh, I want a throttle controller. And then, okay, that's good. Oh, I can't connect to anything. But and then the video plays behind it because there's always just one like video feed. And then you've got this like throttle, and then you can assign that in code. They provide a library for Arduino that says, I want to read a throttle that was in quadrant Q. And then you can just read the value from 0 to 100 of that control that you put in there. And you read that, or it feels like you're reading that in Arduino code that's running on the Arduino Uno. So how it's working is that this is opening a WebSocket connection to the ESP32. And so they give you two options. It's kind of crazy because you do not ever write code for the ESP32. The ESP32 has come pre-packaged with this web server / like this piece of software running on it, pre-baked. And then you write code on the Arduino, and then just like you were for the whole rest of the build process, where it was just like spin the motors and read sensors and that kind of stuff. But now you call these API calls that what they're doing behind the scenes is actually communicating with that ESP32 just over a serial connection. And they have a little text kind of based protocol, text plus JSON actually. And so they are sending, when you say, give me throttle Q or whatever, it's actually just reading out of some JSON structure the current position for everything that has passed from the app to your web server and then all the way to the Arduino code. And so the web server on the ESP32 just acts as like this communication relay thing for your app to be able to talk to the code that you wrote that's running on the Arduino. And then you can set it up to where you say, you tell the Arduino to tell the ESP32 to start the Wi-Fi, and it passes like the password and the SSID over, or you can have it, you can put it in AP mode where it will create its own like web server for you, or its own Wi-Fi network, and you just connect to that. So that's actually what we were doing, which is kind of nifty. And then when you do that, and then you connect your iPad or whatever to that AP, and then the app automatically knows what the IP address is probably going to be and what the ports and everything, and so then it just works. Otherwise, you have to like figure out what the IP address is, which you can through the console on the Arduino. It just like reports information that way, which is kind of interesting.
So if you connect to its own Wi-Fi network, this means you can use it out in the field away from any like actual internet, right? So it's that's cool. That's
it's kind of slick, and it's just serving I did find the source code for the the ESP32 firmware is like a separate repo, which I found that kind of gives some details about how it's working, but it's just sort of acting like a proxy for at least so there's a couple of pieces of a couple of communication protocols. There's like the WebSocket is how you kind of do communications, like the controls and like reading and writing information like that. And then there's the camera feed, which is being presented as a MJPEG feed, kind of like, I don't know if you guys remember, I did talk on that like a while back, but like it's a pretty standard pattern, I guess, with ESP32 cams to be able to just serve up frames as fast as possible off the camera. Let me give you the repo for that.
I have a question.
Yeah.
You just said that the ESP32 comes, pre-programmed and so on. Do you feel any loss from not being able to program it?
I was frustrated in the sense that I couldn't figure out what exactly it was doing, and I couldn't find the repository for it right away. But then I did finally find it, so I was less mad.
Yeah.
Oh, and I think when I looked at the source code, there's another server in there that's like OTA, which I believe is over the air access or something. So I was wondering if that's like how you can update it or something. Is that what OTA means?
Yeah, it's over the air. It's like.
So in principle, you could get like an identical ESP32 and then flash it with your own firmware and like alter the control sort of like flow, right? And you could access the extra processing power if you wanted to do some things the Arduino couldn't do.
Well, yeah. So my plan, though, is to say, for what I want to do is to say, actually remove the ESP32, replace it with a Raspberry Pi, and along with my AI camera system thing, and then kind of flip it on its head, in that like it's the Raspberry Pi making the decisions about driving
instead of the iPad app.
You might use the iPad app also as like you could get it for telemetry. You could use it for like, I don't know, augmenting the driving. You could also use it for seeing. You could distribute the same camera feed but just from a different device, and then make use of that app if you wanted to. But you could put instead of developing code on the Arduino, you would probably be most of the intelligence. You would be writing it on the Raspberry Pi, and then the Arduino just becomes a way to translate the commands from the app, but they're not really coming from the app, or maybe they are coming from the app.
And the AI camera, you have the OAK-D. Is that the same one?
Yeah, the OAK-D. Yeah.
Great.
So I think my plan is to try to go down that route, and if I can get that ready in time for October, I can do the local Robothon competition where they do like navigating around cones and stuff. So if I can get that AI camera to recognize a cone, I really have something.
Had you played with that? What was that? OAK-D after a few sessions? Because I haven't had time to.
I haven't played with it in a very long time. I think I was mostly using it as like an overly expensive ESP32 cam last I used it.
Eric, weren't you also doing something with the OAK-D? You're the one who actually brought it up here, I think. Were you the first one to buy it?
That's right, yeah.
To do with the what, sorry?
The OAK-D Lite. You're the one who first bought it.
Ah,
right?
Yes.
What did you do with it?
It was to replace. It was trials to replace the Intel camera, okay, as actually cheaper and cheaper option, but also easier to use. But it was much work actually. Okay, and so we didn't replace, but otherwise, it's a nice camera. Okay, so basically, I have robots like the Locobot. Okay, a Locobot is a platform for usually research and education. Okay, it's like a Roomba with an arm and a camera on top. Okay, and it's using the model we have. Okay, it's using the Intel RealSense. Okay, and so we're looking into replacing with the Luxonis, so the OGD sensor. For a bunch of reasons. It's for the hardware itself, okay, easier to program, but there is much work, to use with ROS and stuff like that, okay, and also because back then I was working on a tentative technology, basically to make software more independent from the sensor, the actual hardware, okay. So using machine learning to do some translation, and there were interesting results, but beyond that, I haven't touched the OGD. I do have it otherwise.
What is the processor on this? Is it the Intel Movidus?
I think it's the how it's called, the Myriad X.
Yeah. So it's the Intel processor, right?
Yes. Well, it was acquired by Intel. Okay. Yes.
Yeah.
Oh, was it
So
really?
onboard Intel Movidus Mirror X processor.
It's funny the model you show, because now they are really cool, because before they were pretty big like that. Okay. So that's another problem. Okay, is that it's the first OGD, so it's the one. I wonder whether it was crowdfunding at the beginning. Okay.
Yeah, I bought it from Indiegogo or Kickstarter. I don't remember.
Indiegogo
But
or something like that. Yes.
Yeah.
No, it was crowd supply. I don't know.
Yeah.
But otherwise, it's the quality was super nice. Okay? I mean, for at least for the first version, and I hope for the next
because
one.
it's, now the price is almost double. I think I got it for 75 or something, 75 to 80 with the shipping.
Yeah, I was thinking it was
No,
like
it's
100
100
bucks.
yeah.
Why
It's
is the
150
price
now.
going up instead of down? It's been like a few years since it came out. Shouldn't the price be going down?
Yeah, have they changed? Are they more powerful now?
Where is the cost in these things? Is it the lens? I would expect the lens cost would not go down, but the electronics part should get cheaper.
Yeah.
But yeah, high quality optics seem to be always expensive.
They don't have any competition, right?
The one that Eric just mentioned as the thing he was replacing, Intel RealSense, that looks similar. I just posted the link in the chat. You can bring that up if you like. And that seems to be used for a lot of fairly heavy-duty production stuff.
The Intel RealSense.
Yeah, Intel RealSense, the depth.
So the thing is that that was a favorite of many people. Okay, I know several people at Google, and who left Google to create their own company in computer vision and so on, who were basing all their unique technology on the RealSense. Okay, but Intel, like 2 or 3 years ago, announced that it was stopping RealSense completely. Okay,
and it's
so
more
in fact,
it is expensive.
yes, as far as I know, unless Intel changed its mind, is that RealSense is basically doesn't evolve anymore, and it will completely stop by 2028, if I'm not mistaken.
I'm not surprised.
Which is a pity,
Especially
because
now, they're in deep shit right now.
well, it can be hard also to understand, because it's a very successful sensor. Okay, so maybe from the perspective of a huge company like Intel, perhaps it's not that successful. Okay, but it's like to when people were criticizing Apple that their watch, okay, was a tiny market compared to the iPhone. Okay, it's still the watch apparently is a very profitable business. Okay, so I don't know, but a lot of people were surprised, okay, by this decision, and by the future disappearance of a sensor and platform they liked, apparently.
Why don't they sell it?
Sorry?
Why don't they just sell the product? Like
But after you
IBM
have all
sells
the IP behind it,
Lenovo.
okay?
That's
You
what
really-
will happen. I think right now Intel is headed towards like unbundling and sell the pieces to various private
No, I
equity
mean-
and other people.
I mean, sell it before you say you're not going to make it anymore, not after.
Yeah, it seems pretty basic.
Somebody was commenting that the valuation of Intel stock is now basically the unbundle and sell for parts valuation. So if you individually valued the pieces of Intel's business, that's what the stock is worth now. So I do think there'll be kind of a fire sale, and some of this good stuff will probably get snapped up by others.
Yeah, a lot of robotics company might be interested in this.
Hey, didn't this happen to Boston Dynamics too? Google bought it and then sold it again or something?
Yeah, but I think that was more because of the PR issues, right?
Yeah.
That is what I gathered. So basically,
what
they didn't
issues?
want to.
Now it belongs to Hyundai, right?
Right
Hyundai
now, yes.
or such kind of company.
I think I read it in some Wired article that it was causing at that time. I think like so it was like Google didn't want to sell something to military or something, and Boston Dynamics had a lot of military contracts. It was creating some sort of PR issues for Google, and then like I think they didn't want to handle it. That is what I gathered from that Wired article.
That was also probably during the time when like Google employees themselves would like be protesting any sort of military related thing.
But also in general, these robotics companies, it seems to take them a really long time to make it work. And when they do make it work within a year or two, the Chinese companies copy it. Like the dog is what? Spot is, I think, 60 to 80,000 retail. And then the little Chinese dogged ones are like $4,000, I think. They're not as capable, but it's one of those 80-20 things. Like it's 20% of the cost and does 80% of what the $60,000 dog does. So there's some sort of like deep unit economics pressure on robotics ideas, I think.
I wonder how the software compares. Like, what is it actually capable of?
Somebody was telling me Spot software is like pretty much completely proprietary and closed off, and that might be its advantage. I don't know. The Chinese,
I think they sell more of like a service, a robot service than like a platform.
Yeah, and it's like, the most important parts are only leased under very tight licenses, and the part you own, which is the hardware, is like, I don't know, 30% of the value maybe. But I think that strategy fundamentally will not be sustainable. It will be commodity, cheap, Chinese manufactured physical things, and then open source on top. And then there'll be lots of crappy open source code to run the robots. How much is this one? 3,500. Okay.
3,500.
Oh, wow.
Not that.
Last time I saw it, it was like 5,000 was one of these things. And I think Spot is 60 to 80,000 still.
Like they haven't written the price anymore. It's just contact sales.
Oh, that's the
I saw
Unitree
it,
one. They also have
Yeah.
the one with the wheels. That's like very
Yeah.
impressive. It's got wheels on the legs. I think we watched that one.
But also, Boston Dynamics is moving away from hydraulics to electric actuators. So that's kind of interesting because back when Yasha was sort of like giving his inside take on it, he was claiming that the biggest advantage of Boston Dynamics is that they know how to do hydraulics. So if that's the case, and then they're walking back from hydraulics and going to electric, that kind of like kills the whole premise of Boston Dynamics, because I'm guessing everything else can be copied. But this thing, have you guys seen one? It's extremely rugged and tough. It's extremely heavy. You push on it, it feels like pushing on a tank, and the hydraulics are extremely powerful. Like it's not like, typical cheap robot motor stuff with human muscle power is enough to stop a motor from moving and stuff. The Spot's legs and stuff are really powerful. Like you couldn't arm wrestle with this thing. So.
It's very interesting because it looks like there are two extremes where hydraulics are very powerful and also bulky and heavy and so on, and on the other hand, motors are super light. Okay, but then they are quite inaccurate actually. Okay, for us, we went on a competition at the ICRA conference this year. Okay. where it was basically we had a 2-arm robot trying to. The goal was to put to create lunch boxes. Okay, so to put food inside boxes. Okay, and the thing is that we are working with the maker of the robots. Okay, so a robot maker here in Japan, and the thing is that so it's a standard with motors and so on. But each time you move the arm, you have some sag. Okay, so the sag means you extend the arm, and so super nice. Okay, because the motors are calibrated for that. And with the arm or the spoon, you take some load, some food, and the basically once you load a little bit, you go back to your position, but it will go a little bit down like that.
Yeah.
So all the position calculations are off then, okay, because of the sag, and that's because of the motors have their tolerance is quite low, okay, and also quite narrow if I'm not mistaken, okay, meaning that you load them a little bit, suddenly there is momentum on the whole arm, and it just goes down. While with the hydraulic, we don't have that. I mean, if you look at the power shovels, for example. It's with someone who can drive, who knows how to drive those. It's impressively accurate, and I'm not saying no sag, okay, but it's at the kindergarten of my youngest daughter, an old guy. Sorry, I don't want to be an elderly came to take care of the ground, okay, on his own, okay, and he's got a small power shovel, okay, and basically, the ground is quite compacted. So what he does is to draw a line in the ground with his power shovel to put some air, kind of, okay. Super impressed how accurate the guy was. There were 30 children and the parents playing around, okay. And in most countries, in most countries, I think in most places, even in here, that would raise alarms in all directions, and like you need at least 2 meters away from the device and so on. Not at all, okay. And so with hydraulics, it's impressive with the amount of power and also the control. The control we have on hydraulics, okay. It's really impressive, and so. Each time now we have those new humanoid robots that go out. Especially, I remember a discussion for Ford. I think Ford is starting to use humanoid robots in some house, okay, some warehouse. And the problem is that since they are all on motors, the load they can take with sufficient accuracy is actually very low compared to the load declared by the makers, basically. Okay.
I think
hear this kind of argument, but then I look at human beings as kind of the existence proof that low accuracy actuators can actually do very precise manipulation if it's compensated for with high accuracy vision and stuff, right? Like human muscles are not like micrometer precision, but human hands can do very delicate and precise work. And I think that's because there's that mix of like fast twitch and slow twitch and other like muscle fibers, as well as most of the heavy lifting is done by the eyes rather than the muscles. Something like that is going on, I think. Of course,
but we can't do that with heavy weights. Like, the accuracy decreases,
that's true.
right?
So that's why you would have like some specialized areas like mix of precision plus very heavy loads. You probably want to use hydraulics, but like cooking, for example, chopping vegetables, my existence proof is human chefs can do a fairly accurate job with like very fine and delicate like cooking operations. I don't see why electric motor humanoids and other robots cannot do similar level of precision. Anyway, I would bet on electric motors being like the 80-20 solution, and your hydraulics is probably like a very corner case kind of solution, I would think.
It might split into two industries, basically heavy machinery or heavy industry where this hydraulics is used, and where they require like more accuracy and precision, and then consumer ones where it's
I
mostly
think
unitary or.
I think there's another difference, and that has to do with appendages. So if you have an arm and you want to control it with a motors, where you're going to put them. If you put them in the shoulder and you have wires going everywhere, you have a lot of slack problems to deal with. If you put the motors at each joint, then that is very heavy. But if you do hydraulics, the line that transfers the power in hydraulics for a certain size of, let's call it robot, a certain scale, way less and more precise than having wires. And on the other hand, better than having motors in the end effectors.
I don't
like
think
edge compute versus data centers.
I don't think this is true though, because hydraulics, the big problem is you have a high pressure dense liquid that can leak going around in pipes, and you have a heavy pump somewhere that's circulating oil through the hydraulic system, and that tends to be like a really messy maintenance problems. Like, hydraulics keep leaking and have other like continuous maintenance problems. That's why they're usually only restricted for heavier machinery. And the other extreme, the other way to do it is pneumatics, which is even lower precision than electric motors. But pneumatics tends to be very light. Compressors driving like fluid like air around, it can do fairly decent low precision manipulation. So yeah.
I don't know, they have hydraulic brakes on bicycles, very small, no leaks. I don't know if you're right. On a tractor, you might be right, but
Bicycles with hydraulic brakes, I haven't seen those.
Absolutely.
I've only seen mechanical brakes on my bicycle.
But the reason why they use hydraulic brakes is when you have a metal wire transferring the force of the braking, then you have slack and you have elasticity.
Yeah, I get it.
I get the reason to use it.
I'm just saying I haven't seen it. Maybe it's the e-bikes or something. But
no.
Regular bikes have hydraulic
top line use hydraulics now.
Okay.
And the big thing is, how do you get air bubbles out of the system?
And I think the other consideration is how much pressure do you need to run the hydraulic system at? Because the heavier the load you want to move around, the higher the pressure the hydraulic system will need to be at. So, anyway. Yeah.
It's interesting the spectrum between hydraulic and motors. I mean, it looks really to extremes. Are there any technologies in between? I don't remember ever discussing.
I think motors are the in-between technology. Pneumatics is less precise than motors, so the spectrum is pneumatics is the least precise, hydraulics is the most precise, and motors are in between. And then you've got all those weird, fancy, smart materials, artificial muscles, all that stuff is still in the labs. Has any of it actually made it to commercial?
Sorry, changing topic a little bit, is that apparently recently there was something called the YaRG 2024. That's the China's largest robot exhibition. I sent a link in the comment section. Okay, I got the link today. Okay, so I haven't watched it, but apparently it's pretty big. Yeah? So there might be some interesting.
Yeah.
We talked about Unitree a bit earlier for their cheap dog version. Okay, and I remember this year at the ICRA. Unitree had a very big booth at the event, and they made a lot of very showy demonstration of their humanoids and their some robots that auto balance automatically, okay, and dogs and so on. Okay?
All the labs have Unitree now, basically. Like it's just 2,000 bucks. Just every lab just buys it.
Would you know if so? Of course, it's cheaper, so more people, more laboratories can afford it. But in terms of programming, SDKs and so on, is it easier to use than
that? I don't know, but in the lab here there are like a couple or 3 or 4 hot dogs here.
Because that's one thing that I really appreciate with a lot of platforms we get from China. Okay, so with Meyer, we spend a lot of time, and still, on the High Wonder company. I think it's from Hong Kong or Shenzhen. Okay, and basically everything is open source. Okay, and you ask them for the 3D models of your robot, and they give it to you basically. Okay, a few other companies like that we have in the network, and that's super nice. Okay, is that everything is open. Okay, and the company for the Galaxy rover it's Sunfounder, right?
Yeah.
Is this a Chinese company, an American company?
Yeah.
So I don't know, all these things completely hackable. Okay.
Red, you
But
had
the
shared
software
the
is
schematic. Just wanted
Yeah,
to ask, like, I didn't find the solar panel to charger circuit in that.
Yeah, it's definitely not very well explained either. Like, if it's in there, I'm not sure what
Okay.
the pieces are.
But yeah, sometimes they use strange characters also to explain things, right?
Well, yeah.
I mean, like the data sheet you were showing like a couple of weeks ago.
Yeah, that's right. Yeah.
Okay.
Yeah, as soon as the components themselves don't even have data sheets in English, you might be in for a bad time. And I was trying to reverse engineer the control app to be able to talk to my own server, and it's like failing to connect, and it flashes up, some Chinese characters as the error message. I'm like, oh boy, I'm in trouble. And it goes so fast, I can't like snap a screenshot of it to get it translated.
Yeah, stuff is changing so fast. Anything we do, it's like 6 months later we find that there's probably not a good reason to do it because it's done cheaper and better by some Chinese startup or something. So it's hard to figure out what's a good sort of like it's a white space to try and operate in for a group like ours. I mean, I'm having fun, but I'm still. It's the fun is there, but it's not clear where we can actually make contributions. Like I'm not going to attempt to build a better rocker bogie than the Sunfounder guys.
Right.
I think you should. I think we need like a slightly higher budget version of the rocker bogie.
Yeah.
That can be 3D printed, maybe.
Yeah, I mean, yes, going higher budget kind of is like an obvious sort of like expanding scope, but there's still no mission objective in there. Like the Sunfounder clearly is. If I wanted to recommend to somebody this is the kit you should buy to learn this particular style of robot, it's kind of obvious that I would tell them go buy this. It's like easier than designing your own, cheaper than designing your own. So then the question becomes, what kind of rover are we trying to build and why? What's the mission profile? Like this, I think we were starting to go down that route with the Yakasar, and I think Yasha's reasoning was the absolute dirt simplest, robust mechanical configuration is 2 wheels with a dragging tail. That's how we ended up at the Yakasar. And we kind of like went partway down that path. And I think the overall mission intent was, yes, we'll spend more money, but the more money would be to ruggedize it for like desert operations and like better power management or something like that. So I think this is a good discussion to have. It's like, what can and should we do that's either not worth it for like either the big expensive companies like Boston Dynamics to attempt and not worth it for the cheap mass production Chinese companies to do either. So that's an interesting question. Is there like a sweet spot for our kind of building?
There are definitely opportunities in what exists. Huh? Yeah, even if you take, for example, robot dog, I don't know about the programmability of the Boston Dynamics one. Okay, the hardware is apparently definitely high quality, but for the SDKs, it's not super clear. Okay, and it looks like a lot of IP and protection. Okay, so closed source and so on.
Very close.
And from Chinese competitors, it's super cheap. It's very likely low quality. Okay, or should I say rather I should say lower quality. Okay, some of them are surprisingly good, honestly. Okay, but then the software is super messy, but you have it all. Okay, you can completely. They do it at the lowest level. Okay, so you have a serial port, and on top of that, you have a Python script that does a serial reading writing. Okay, and it's isn't it a thing to make a cheap dog with a good software? Okay, it's the quality of the SDK from Boston Dynamics, but the openness and the hackability of the Chinese version.
Yeah.
Okay, for example, it's also Red mentioned about replacing the ESP32 cam by Raspberry Pi and putting the OGD camera. For me, that's still interesting and also potentially innovative in the sense where there are more communicating active components, inside the same build. Okay, we talked about the potential power in interactivity between several compute systems on a device. Okay, I don't know. I don't see much of that. It's growing. Where there are more big places, big laboratories talking about those. Okay. We talked about subsumption architecture, where low level would be an Arduino and high level would be a Raspberry Pi, such kind of stuff. Okay. So I know it looks like we see a territory, okay, and perhaps there are some shadows we need to put some light on, but apparently at reach.
I think you're getting at one interesting idea. Like we've had two ideas along these lines. I think actually the first one was yours, which is the place where you can have something interesting is in operating system level, and everybody's unhappy with ROS, and we've gone back and forth on that. And you had your proposal for a boss, and Rhett, you had that language of mid-level command language for robotics that was one of the first things you were trying to do, I think. So
yeah, I also have the YaRG API kind of web server services thing, which is now it's separate repo, by the way.
So this stuff I would call kind of like a horizontal architecture for open robotics. So the reason this is valuable is you look at something like Boston Dynamics, not only is it closed sourced, it's super vertically integrated with their hardware. So even if they opened it, it probably wouldn't generalize well. They probably use custom boards and custom like stacks and everything, right? So that's going horizontal across hardware in an open way is valuable. I think that's where projects like BOSS or your VPN type stuff, all that is the horizontal logic. On the vertical logic, though, I think the other interesting thing we've done is this whole take this commodity robot stuff, pull out the cheaper compute, put in better compute. So with Tumblr, it was like replacing the Arduino Nano with the ESP, and here you're talking about replacing the ESP with the RPi plus camera. So it's kind of interesting because that's vertical logic. So in a way, the interesting sweet spot is at the intersection of upgrade the commodity lowest common denominator cheap hardware to the next grade hardware, and then do better software at that level. So I think that's actually something that hits both, because the problem if you do only one of them is if you try to like write a new operating system to replace ROS, and then you're faced with having to either run it on the closed Boston Dynamic type robots or on the cheap Chinese robots, it doesn't work. The hardware, neither kind of hardware is suitable. On the other hand, if you just do hardware upgrades, you're lost at software. So I think it's interesting to think about the intersection of take off-the-shelf models, upgrade the hardware just a little bit so that it becomes like a modded, I don't know, overclocked versions of the Chinese robots, basically, and then try and write better software on it. So I think doing both is interesting.
I'll share these robots this person was making. Really interesting. I think the hardware is mostly 3D printed, so you could really make like high quality rovers with just by 3D printing and extra stuff. It's
Koya?
I found this person on Twitter. So it's Sequoia Taylor Alexander. Uh, the Twitter handle is TL Alexander. But the robots are really like high quality. So this is the one we were trying to make, kind of the one with a tail and two, and it's really powerful. With
I'm seeing a four-wheeler here, not a two-wheeler with tail.
just wait a minute.
But just to be clear, when I said upgrading hardware, I didn't mean mechanical hardware. I think that should be
Okay.
like commodity. I meant compute hardware. So things like replacing cheap Arduinos with ESP32, that type of upgrade. But yeah, this looks solidly built.
This is the one kind of we were trying to build, or this person has already
Oh,
built
yeah.
it.
Oh,
You have the battery as weight at the tail.
Oh, that's actually an interesting place to put the battery since you need to weigh down the tail anyway. So put it down there to hold the tail down.
No, I was showing my daughter the constructs version of it that has like two pieces of plastic as the tail. I was telling her it didn't work so well, and she was looking at it. She's just like, "Why didn't you put a wheel back here?" I'm like,
I actually don't get that either. It seems to make sense to put a dragging wheel there. Yeah, this might be an interesting exercise for a future session. I think we're onto something with this comparison of like, high-end Boston Dynamics versus Chinese. And if we did the full sort of analysis of like, actuators, physical body, batteries, power management, compute, everything, and look at what the two extremes tend to use, it I think will give us ideas about like what are the strategic things to upgrade from the Chinese stuff so that you get a lot closer to the Boston Dynamics high end at like a fraction of the cost. That would be an interesting challenge. It's interesting to see that all these cheap robots, they seem to use the same kind of crappy battery. So
Indeed, yeah.
it would be interesting to see, is there like a slightly improved battery you could buy and replace that would really improve the sort of like ruggedization? Like the batteries that came with the Sunfounder, the little blue ones, taped on with Velcro, mine didn't stick properly, so it keeps falling off. So I'm going to have to like strap it with a cable tie or something. But I was thinking, this battery is not probably something I trust in, like, I don't know, 100-degree weather out there or something. So if it goes out in like really tough weather, I would probably want a more rugged battery. What's a more rugged battery, right? So this is the
Well, internally they are all the same, right? I think they are kind of made with the same kind of cells. It's just the packaging that matters then.
So this one I think is better than most. Like I think I bought it when Yasha recommended it. He said buy the cylindrical ones rather than the flat ones, because the flat ones, which usually have that yellow coating on them, they tend to explode apparently. And the really high power, large looking ones that they make for RC cars, they're apparently really crappy and like catch fire all the time. So this blue one is what Yasha recommended, but it still seems like it probably should have like a little bit of cooling or something if it's out in like rough weather. I don't think it would stand up to water. I don't think it's waterproof. So there's like a bunch of ruggedization things that need to happen. But yeah, so that's just an example of what I mean by take a standard cheap chassis and see what are the upgrade points and upgrade paths, and like what's the leverage of upgrading like different pieces of kit. Like it's already clear ESP32s are the way to go, right? That's a really good upgrade option.
why didn't you mention more and brighter LEDs? Your favorite feature.
Oh, and the other area that we talked about a while back is cell network radio connectivity. We looked at that briefly, right? The particle boards and things like that. That seems to me like a must-have feature to go from like either indoor domestic or like some, I don't know, relatively easy Wi-Fi access point to proper remote control.
I still think the mesh network thing is a very intriguing.
Is that the one you tried
Concept.
with your first build with the small RF transmitter?
Well, it's sort of the basics of that, but like there are mesh network kind of, I don't know, organizations or projects ongoing that like they're kind of like ham radio operators, but at a smaller digital scale. Alternate internets.
There's we were talking about the drones being used in Ukraine. I looked it up. I think that has a range of like a few miles, and that's like straight up RF transmitters. So, and those are easily jammed. Apparently, the loss rate is like 90% just through like RF jamming techniques. That surprised me. Like the way the Russians bring down the Ukrainian drones is mainly electronic warfare. Like, and because they're so cheap, it's okay to throw 100 drones, and if 90% get killed by like electronic countermeasures and 10 get through, that's still a win. It's cheaper than artillery apparently. But it seems to me that mesh network or some other like more sophisticated way to do it is probably a better peacetime way if you don't want to like lose 100 drones for every one that gets through, or 100 rovers for every one rover that survive in our case. What is the thing you were showing, Anuraj?
It's the ESP32 board with a LoRa transmitter on it. So you could have, so it's like if you have written something for ESP32, then you could buy this board and then have a long range connectivity with it. So depending on the variant you buy, you can either have these frequencies.
It should probably be on our list of things to eventually investigate.
I will eventually have to plug in my Blues wireless things that I bought to something and try it out. The salesman did stop messaging me.
Have you guys done? Oh yeah, this is the one I was looking at. I was tracking this project for a while. It's called Caribou Light. So I was briefly interested in this idea called software-defined radio. This was a crowd supply project that does that. So I don't quite get it technically or how it differs from many of the other paradigms, but so there's lots of like interesting things like this coming out. And this fits as an RPI hat. It's it's FPGA. Yeah. Oh, I've started reading the Substack by a guy who's specialized in radio and radar and stuff. So it would be interesting to invite him to come chat with us one of these days.
That'd be great, but we need to do some learning first. I would need to.
Yeah, I think we've kind of like reached a point of maturity where several functional subsystems we need to like talk to people who know more than us. Radio is one of them. Batteries is another. Power management in general. Power management and radio are two topics where I feel our conversations aren't at the level they should be, and we need people who know what they're talking about.
I wonder if we really should be going deep into radio. I prefer to have as many components, below the black box. I mean, I wish we could do it for battery too, but.
You mean what do you mean below the black box? You mean like building our own radios from scratch or something?
No, the opposite. Just buying off the shelf and pretending it's magic.
I mean, that's what we're doing here. I mean, we're exploring off-the-shelf magical components.
I'm on a higher level than that. Same thing. What I'm saying is, we have to decide where we focus our attention, and as we go down, and as we go up, we go up. And I don't know if maybe we can have a mixture Of some parts of the robot, we look at a high level, and some parts we look at a low level.
Yeah. Radio is one of the things, though, that I think is interesting to go lower level, because rovers fundamentally operate in places without good infrastructure. Okay. Oh, while we are on radio, I did my first ever RC controlled Lego Technic model. This works amazingly well. It's like, yeah. Have you guys built Technic motorized RC controlled models? They're really cool. And you don't even have to think. Like, it's just, yeah, even the pieces are like standard Lego pieces.
Mm.
Motors and batteries, it all connects in a modular way. I posted a video on Wattcast of the little helicopter model I built. But yeah, this sort of thing, though, I think is like extremely low power with a range of maybe 10, 15 meters at most, backyard level stuff. So if you wanted to do something like Mojave Desert was our sort of like thing we were always talking about, like you literally do have to like somehow connect up to a cell network, and sounds like that'll be the most power hungry part of the rover. Like we looked at that at some point. Like radio is extremely power hungry, right?
Yeah.
Like more than motors and stuff almost.
And also suddenly like bandwidth is a real big issue. Like, do you want to see a photo of where you are? Because that's not that easy.
This is the architecture you were mentioning for the Sunfounder. You wanted to like move all the intelligent processing of the iPad and onto the RPi, and then if you had like an OGD type camera, all the intelligent vision would happen on the RPi, so you would never actually send high bandwidth video back to like the remote command station. You might send like, occasional picture just for fun, but any heavy duty use of vision would happen on board on the rover itself, right?
Yeah. Yeah, you wouldn't be offloading certainly to somewhere else. The idea would be to operate as locally as possible, and so for the competition in particular, it's about autonomous and like onboard operations. So.
Yeah. Right. Oh, looks like we're already 10 minutes over.
10 minutes past, yeah.
Yeah. All right.
Okay. See you next week.
All right, cool. Catch you later.
Cheers.
Bye.
Bye.